Alright, so I've been gone for 4 months. Yeah, I've been working and doing other real life things so I can post. But I still stay up. And I took a break from the 2D engine, but I spent a lot of time, and I want to say, learning from Handmade Hero, the Cherno's game engine series, real time rendering, and game engine architecture. I want to mainly say those four because those four condense, I think, the most right amount of information that you're getting, and it makes the most sense. So if you put those all together, now this also led me to spend a lot more time on math mostly. Now I already exposed myself to Euler angles using the 2D engine, but I wanted to also understand what quaternions are because I know they stop gimbal lock and they're good for rotations and animations, and GJK, which we will need later for a physics system, but I need to read more real-time collision detection, which I don't have the time to read now because I need to read the other stuff first. But I'm pretty sure that goes into more depth. Now, granted, I do want to say this takes a lot of time to actually learn and understand this stuff. Like, I haven't read all the texts I just mentioned because it takes me like even 2 weeks to understand what a quaternion, how it works in the first place, and I have to watch like the same 5 videos for like 10 times. So when I'm referring to something like real-time rendering and the game engine architecture, you should probably read the introductions and bounce around topics you find interesting or things you have no idea how they work, because I mostly do this to expose myself to stuff that like I'm like, oh, that's interesting, right? Because realistically you don't know what you don't know, and you don't know how they correlate yet, because if you don't have that understanding, well, you don't know, so you have to go figure it out. But I slowly find that the more time that I read these kind of things and I spend more time doing these kind of things, it's easier for me to read more like the technically stylized papers, right? Because they kind of go into a lot of depth, and they're kind of assuming that you have like knowledge of these things, right? Now, I want to mention too that my first idea that I'm going to show you before I talk about what you see on screen is I was trying to make a whole graphics API. Like, I was going to go down the route of making a rasterizer, then like a ray tracer, right? And I was going to learn through Tiny Render. But after even learning like Bursenhand's line algorithm, which is like, yeah, that's the beginning, I was starting to realize, wow, we are going to have to do so much. Like, a graphics API does so much for us, right? And I did that, and I made a rasterized triangle, and then I read about the wireframe, and I was like, okay, you know what? This is gonna take a lot more effort and work. So what I decided was, okay, instead, let's combine the approaches, because realistically, we've done some OpenGL before, so we should use OpenGL because we know it's well documented, and we know that we can go to Vulkan afterwards, so they're both uh, compatible with pretty much everything, right? Whereas DirectX is kind of locked on the Microsoft interface, right? So I'm pretty sure we're only going to get Windows and Microsoft's Xbox, right? That's it. So it's better to go this route. And also, it saves us a lot of time because realistically, if you want to write every single thing from scratch, that's going to take you a lot of time. If you see any of the people who actually do that type of work, right, you're going to need a great understanding. So it's better off that we use the graphics API and acquire this actual understanding, and then later on we can say, you know what, maybe we want to attempt this, because once again, that's a lot of work. I just want to mention that. Now, let's see. Obviously, I haven't mentioned what I'm showing you now, which is this 3D engine, and I want to also say that for this I wanted a better project structure, like an actual working in with Visual Studio, because my last project, the 2D engine, when I say it's like 2,000 lines, I don't mean that means any sort of complexity. I mean that like I can steadily understand how having a bad project structure is just horrible to work with, because it's just very annoying to actually look for things and like what things actually do, and like there's just not like any useful comments, if any. So yeah, we worked on that by copying kind of like the Cherno structure, where we have our vendor folder and source folder, right? I'm pretty sure it's pretty common, but like once again, my project structure was horrible, so I have to go follow someone else's style of structure, and I've been liking that because it makes it so much easier to add stuff in and to understand what everything is doing, especially with like the inclusion of actually adding useful comments, especially in the headers, because I'd rather do that than just comment every single like line about what something is doing, right? Because I feel like if you have a function that's named something and it does something, well, unless you're explicitly using some certain type of algorithm that you want to explicitly state, then yeah. So let's see. So now so far, showing you just basic shapes, as you can see. This also has a full 360 camera, so you know we're using our Euler angles here. It's also clamped though to negative 89 degrees and 90 degrees, because if we go past the rotation, we're going to get gimbal lock and we're going to get some weird effects, right? But most FPS cameras are like this, and I like it because it kind of simulates a neck, right? Like everything that you'll ever play that has an FPS game is kind of like that anyways. But as you can see here, we also have the AABs and the bounding spheres. So these are done in the mesh, so I can just call these whenever, so I can just enable or disable these. So this is really nice because I've been working on a model loader that I'll show you shortly after. But we're also, you notice there's light in here, but we're using basic blend Phong. So I used Phong like many people, and then I just used blend Phong after I learned what blend Phong was, and the difference was just that you're calculating the reflection vector instead of the half vector, right? So that's very easy to implement, so that's nice. I was like the coolest thing, I thought, right, rather than the actual shapes, because after you make like the first cube, right, it makes sense how you can make a shape, right? Now when we talk about the object loader, I will say that I did not use TinyObj or async because I wanted to do some file parsing and learning how that works, right? I understand that like you could use the library, but the way I view it is if it didn't work, right, then I could just use the library. So just saying that, right? So it's not that opposed to libraries, because I'm using SDL because I don't want to do the window or input handling. Like I know I could use the Windows API, but that's just a lot of work I don't want to do, right? Even though it's simple, but it's kind of annoying, right? Rather than SDL's interface is kind of nice. You just easily make a window and easily add input handling. So let me see here. I got some other notes that I want to talk about. Oh yeah, so now I'll probably show you this, the wireframe, just so quickly you can see how all these shapes are composed. I'll turn these off too so it's not as distracting, right? So as you can see, right? Now, also, what do you call it? Now I'll show you the object loader. Yeah, I know, I have notes and I still, because it's a lot of information and that I missed, let's see, 4 months, this would be 4 months, so I guess only 3 months of actually recording progress to actually explain everything, right? But shortly after now, I'll show you the OBJ loader. Let me just switch over to that. So now you can see the model. Now I got this model from Poly Pizza, right? So this is just a free model that I was using to test it. Right, and you can see our light sources up there, so we don't have multiple lights, and it's dark over here. But as you can see, oh, you'll notice this magenta-ish thing. Yeah, it's a missing texture, so the MTL file I think calls, it's looking for some PNG. And before this, I have a logger and error system, just the basic system that I've been working on, because I want to also include that, which I've liked because it's actually helped debugging the most. So like that stuff is might be the most useful thing I've actually added into my learning. Right, it's using a logger and error handling. That stuff is so nice. But anyways, beforehand, this would have just closed the project if I didn't have this missing texture. So we kind of copied like the Gary's mod. If you ever play Gary's mod where you have the missing textures and it's like magenta checkerboard or whatever. Nah, I don't have the checkerboard. It's just magenta, right? I kind of do want to do that, but that'd be funny. But yeah, we can also calculate once again the bounding spheres and the AABs because that is included in our mesh. So when we actually we have to add that to the OBJ loader to calculate the bounds and stuff, but we can still easily the same function call them, right? So that's nice, right? And if you want to see the wireframe, and here we go. Yeah. So let's see, what else do I have in here? Now I think that sums up to catching us up to where we are, right, in terms of where the project is and a lot of the reading and stuff that I've been doing, right? So I want to talk about a lot of notes that I actually have, because I have tons of notes and resources and stuff that I want to share, obviously, but I wasn't able to post them because the first 2 months of a new account you can't like post anything. So this is actually good now that I've posted walks. Now I can post stuff like links. So anyways, I'll talk about what I have planned. Is one of the most interesting things I've been focused on is a forward versus deferred renderer, right? And so if you don't know what that means in simplistic terms, is that in a forward rendering you would process everything beforehand. Mostly we're talking about lights that people like to say, right? So this is all done beforehand, but this is very expensive because this would be pixels times the amount of lights, which makes it very, very expensive, right? Rather as that if you did it as a deferred renderer, you could do all the things that you needed to do beforehand and then calculate all the light afterwards, which makes it a lot easier. But the only reason I'm speed running that is because the main thing I want to get to is I want to use aliasing like MSAA and SMAA S2X and SMAA4X, right? Now that probably sounds very specific because those two methods of SMAA use MSAA in them, right? So it's different than normal SMAA, which is applied as a post-process, right? So now, why do we care? Well, if you're a gamer, you probably know what TAA is, which is temporal anti-aliasing, which it kind of has a bad name, even though I think most of the problem with TAA is that there aren't other good options. Since TA uses the current frame and the previous frame while performing a subpixel jitter, is what they call it, this kind of gets a smear effect as if you're playing a fast-paced, like explosive type of game, where many things are changing frame by frame. This can be kind of negative. Now TAA usually, and its counterparts, because there's a lot of aliasing methods, are very good at eliminating shimmer, right? But in general, I want to mention that there's just a lot of aliasing methods that go from traditional FXA, MSA, MLA, SMA, then a bunch of proprietary aliasing methods, right? So various companies that come up with their own methods. So why do companies use TAA? Well, pretty much everyone is using a deferred rendering pipeline because most of the engines offer it, and it's just cheaper overall in the terms of like you don't have to think as much, right? So you can just slap TAA and you're good. You don't have to think about all the light cost and all this stuff, right? But the other reason is forward rendering I think has just been moved away from because it just requires a lot of that work, like I just said, and forethought from developers. So they just don't want to incur more thinking on the terms of a developer pipeline, because most of the time you have deadlines, right? That you notice from the industry, right? This is just common occurrence where it's like, oh, we have to do a deadline. So they kind of want to focus on adding features that you can see as the player rather than something technical, right? That's gonna definitely require a lot of work and thinking. Otherwise, it's just not gonna work. So they'd rather just take the chance of, okay, we know this works, right? And it's faster to do in general, so they just do it that way, right? Now, you can also hire more developers as well, because if you are, what do you call it, doing more of this custom type of pipelining stuff, then this requires more understanding of engine architectures from my understanding, right? Like, so most people, I don't think, make engines as much anymore in game industries, right? That's more of like the old thing of where people were hardware limited, so they would just make an engine that would solve their issues while also doing things that they wanted to do, right? And also, Unreal Engine and Unity are just widely available with many features nowadays. We have to mention that. Like, they just have so many things that you get for free too, especially with like the free fabs and stuff, right? So you can't complain, right? Maybe that, okay, everyone's stuff looks the same or stuff, but Unreal does give it to you for free, so, and Unity as well. So we cannot complain on that part, right? So now, are there any solutions to making forward rendering working, right? Yeah, we can use a method like forward plus, which clusters the lights in a way that makes it so it only calculates the lights that it is affected by each cluster. Now, once again, I haven't implemented any of this yet, but this requires kind of locking in our structure, and you're probably going to be seeing a little piece from this document I saw of someone talking about the Doom render, and you can see how the camera clusters work in this sense. Let's see. I know. And alright, I want to bring it back to, so why does this matter for this whole aliasing argument? Well, MSA can only be applied at the beginning of the pipeline, so forward rendering, right? But it doesn't work with deferred rendering, right? So you can use base versions of SMAA with either version because it's just post-processing, right? So at the end of the day, that just works, right? But S2X and SMAA4X, which, if you're wondering what the 4X stands for, it means 2 times MSA, 2 times SMA, and then 2 times SMA temporal, right? With 2 samples. So those 2 times each mean 2 samples, right? So like if you heard of 8 times MSA, that would be 8 samples, right? And you'd probably be seeing some on-screen footage and stuff, right? And now, yeah, so since we can't apply it at the end of the pipeline, that's why we care about how does a forward plus render clustered lighting work, right? So I know I speed ran that, but I just wanted to give enough background to understand what and why we care and what I'm trying to do and what some people have talked about and even research that people have done on, rather than say some typical stuff about like, oh, TA sucks, right? Like how you hear everyone just complain, right? But just saying like, oh, just change it, right? Without understanding is very, like, it's not that good in terms of getting your opinion across, like you gotta get the sentiment, right? Like, okay, we don't like it, or we understand why we don't like it, but then how do you know why we can't put it in? Like, that seems to be a big argument, right? And I think it would just be cooler, yeah, if we could implement this stuff ourselves, use all these resources and papers that have been made to make this conclusion, and conclude it ourselves. Now, finally, that's the end of everything I have to say. I wasn't able to post resources for the first 2 months because I had a new account. So you can't post links, but I made this account to just only watch in relation to programming and to post here, right? Now I have a Discord I made where you can join. It's called the Village Hidden in the Heap. Or basically, I have a resources page that you can go to that condenses a lot of information where to get it, right? So it'll have links to things and topics that I find that are like that I think are really useful, right? And it's free. I'm not asking you anything. Also, I'm not really expecting people to want to talk in this Discord, but if you do want to like talk or share or learn uh, something, that'd be cool. Because I know a lot of people are good and they're interested in a lot of different things, so I think that would be interesting. Like, but most likely I'll check it once in a while since I do work and I have to actually read and implement more stuff, like I said, like what I just told you, and I have a lot of notes on that. So we do have a good roadmap. So, anyways, I'll see you next month.